Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 5. Today we are talking about fractions, decimals, and order of operations. The objectives in this section are to write fractions as decimals, compare decimals and fractions, simplify expressions containing decimals and fractions using order of operations, solve area problems containing fractions and decimals, evaluate expressions given decimal replacement values. All right, so first up is writing fractions as decimals. To write a fraction as a decimal, just divide the numerator by the denominator using long division usually. So for example, 3/4 means 3 divided by 4. If you set that up as a long division problem, you would find that comes out to 75 hundredths. 2/5 means 2 divided by 5. If you do that as long division, it comes out to 40 hundredths or 4/10. Either one would be correct. All right, so for the first example, we have -3/8. All right, so I think I'll start over here. First, just remember that the answer is going to have a negative sign on it. We'll put that aside for a second. You set up the long division like this with the 8 outside. Tack on a few extra zeros. 8 into 30 goes 3 times. 3 times 8 is 24. 30 minus 24 is 6. Bring down a 0. 8 into 60 goes 7. 7 times 8 is 56. 60 minus 56 is 4. Bring down another 0. 8 into 40 goes exactly 5 times. So that's the end of the problem. Remember, there was a negative sign on it, so -3/8 as a decimal would be -375 thousandths. All right, here's one you can try if you're feeling frisky. 5/6 as a long division. That looks like this. Let me move myself out of the way there. 6 into 50 goes 8 times. 8 times 6 is 48. 50 minus 48 is 2. Bring down a 0. These are not really lined up all that well. 6 into 20 goes 3. 3 times 6 is 18. And now something interesting happens. This hasn't come up in any of the other examples. The same pattern just repeats over and over. You keep getting 20, 20, 20. And what that means is that 5/6 is what's called a repeating decimal. You could keep this going as long as you want. You'll just keep getting more 3s. So the way to write that exact value as a decimal is like this with a bar over the 3. That means the 3 repeats forever, okay? And actually, that should be an exact equal sign. They shouldn't have put a approximately equals there. What will sometimes happen in a problem like this that has a repeating decimal is they'll ask you to round it to the nearest hundredth, to the nearest thousandth. So, for example, this would be rounded off to the nearest thousandth. All right, 3 and 5/16. We have a mixed number. What you do there is just take the fraction part, 5/16, set that up as a long division problem, and this time maybe I'll spare you the details of the long division. I won't talk you through the whole thing. If you want to take a second and look that over, you can always pause the video. 5/16 comes out to 3,125 10,000ths. Remember, there was a 3 attached to it. That means that 3 and 5/16 is 3 and 3,125 10,000ths. All right, 3/5. That's a pretty easy one. Oh, they're doing this one a little differently. Now, you can do this one the same way we did the other ones. Nothing wrong with that. They're just pointing out that because 5 is a factor of 10, it's also really easy to just multiply the top and the bottom of this fraction by 2. So instead of 3/5, it says 6/10. And I believe we talked in a previous section about fractions that are over powers of 10. It's very easy to write those as decimals. 6/10 is just 6/10. Okay. But again, you could also do it using long division. All right, this one can be done the same way. 50 is a factor of 100. So if you multiply the top and the bottom by 2, that'll make it 6 over 100, 6/100. That's how you write that as a decimal. All right, now we get to comparing fractions and decimals. To compare fractions and decimals, just write the fraction as a decimal. So for example, if you want to compare 125 thousandths and 1/4, change the 1/4 into a decimal, the way we just talked about. 1/4 as a decimal is 25 hundredths. And in an earlier section, we talked about how to compare these two decimals. The reason I know this one is bigger than this is because it has a larger tenths digit, right? They both have 0 as the whole part, but 2/10 is bigger than 1/10. That makes this bigger. All right, insert less than, greater than, or equals to form a true statement. So the two numbers being compared are 1/2 and 5/400. As a decimal is 5/10. So the way I would compare these two, the two zeros are the same, the two fives are the same. However, if I put a 0 on the end of this, 0 is less than 4. Since this number has the smaller hundredths place, the first number is less. All right, here's an interesting one. We're comparing 0.5 repeating with 5/9. So if you do the long division for 5/9, and I'm actually going to ask you to do that now. Go ahead and pause the video and do the long division for 5/9. You find that 5/9 is 0.5 repeating. Okay. So these are just two different ways to write the same number. These two numbers are equal. Okay, same kind of problem, just with different directions. They want me to write these numbers in order from smallest to largest. 1/3, 302 thousandths, and 3/8. So let's convert 1/3 and 3/8 to decimals. 1/3 is it's actually 0.3 repeating, all right? This much of it is good enough for this problem though. And then 302 thousandths is just 302 thousandths. That's already a decimal. 3/8 is 375 thousandths. I believe we did that example earlier. So these three numbers all have the same tenths digit, but they all have different hundredths digits. So the hundredths digit in the middle number is a 0. In this number, it's a 3. And in this number, it's a 7. So that's actually the order that these numbers would go from smallest to largest. This one is the smallest. This one is in the middle. This one is the largest. So the answer would look like this. Okay, order of operations. So remember PEMDAS, please excuse my dear Aunt Sally, stands for first step is parentheses. Simplify everything in parentheses. Second step is exponents. Then multiply or divide in order from left to right. Now remember, that means if you have a division to the left of a multiplication, you do the division first. And the same thing for addition and subtraction. They go in order from left to right. So if you run into a subtraction before an addition, you do the subtraction first. All right, our first example is 897 8/10 divided by 100 times 10. All right, so the two operations in this problem are division and multiplication. Those are done in order from left to right. So the first thing I'm going to do is 897 8/10 divided by 100. And I believe it was in the last section dividing decimals where we talked about dividing by a power of 10. You just move the decimal point the same number of places to the left as there are zeros. Okay. Since there are 2 zeros in 100, this decimal point is going to go 2 places to the left. Whoops, I just noticed a typo here. I didn't notice this before when I was looking at this before I started. That should say 8 and 978 thousandths. And I'm probably going to have to fix that on the answer also. All right. Here, let's do this. 8 and 978 thousandths. Okay. All right, so, and then multiplying by a power of 10, we talked about that 2 sections ago. Move the decimal point to the right. So this decimal point would go 1 to the right. The answer should be 89 and 78 hundredths. But they wrote it backwards because they had made this mistake early on. It can happen to anybody. All right, this should be 89 and 78 hundredths. Okay, so let's cross that out. Okay. Moving right along. We have -8 and 69 hundredths times 3 and 2/10 minus 1 and 8/10. 8/10. Okay, so I see parentheses. I see multiplication right here. And I see subtraction. Okay, well, the subtraction is going to go first because that's in parentheses. So we're going to do 3 and 2/10 minus 1 and 8/10. 8/10 is 1 and 4/10. Okay, change this into this. And now we're going to multiply -8 and 69 hundredths by 1 and 4/10. And you can check that comes out to -12 and 166 thousandths. All right, next we have the square of -2 and 3/10 plus 4 and 1/10 times the sum of 2 and 2/10 plus 3 and 1/10. All right, so let's see what we have here. We have parentheses, so we should do what's in these parentheses first. 2 and 2/10 plus 3 and 1/10 is 5 and 3/10. So now we have an exponent and we have multiplication. We should do the exponent next. Now, this is the thing we've talked about many, many times. We are squaring a negative number. So this is another way of saying -2 and 3/10 times -2 and 3/10. It's a negative times a negative. And that's why that came out to be positive 5 and 29 hundredths. Okay. So 5 and 29 hundredths plus 4 and 1/10 times 5 and 3/10. Now we'll do the multiplication. 4 and 1/10 times 5 and 3/10 is 21 and 73 hundredths. And finally add these two together. The final answer is 27 and 2 hundredths. All right, here's one that you could try if you're feeling confident. 20 and 6 hundredths minus the square of 1 and 2/10 divided by 10. And that whole thing is divided by 2 hundredths. Okay, let's see. Remember that the big fraction bar is a type of grouping symbol. So this whole thing up here is in parentheses. We need to do all these things before we do the division. So out of all these things, there's a subtraction, an exponent, and a division. We should do the exponent first. The square of 1 and 2/10 is 1 and 44 hundredths. So now we have subtraction and division. The division comes next. We're dividing by 10. That's going to move the decimal point 1 place to the left. So that becomes 144 thousandths. Now we'll do this subtraction. That comes out to 19 and 916 thousandths. And when you divide that by 2 hundredths, you get 995 and 8 tenths. All right, that brings us to an area problem. The area of a triangle is 1/2 times the base times the height. And they want me to find the area of this triangle. The base is 7 meters and the height is 2 1/10 meters. So we are going to multiply all of those numbers together. Substitute 7 for the base, substitute 2 1/10 for the height. And now we'll change 1/2 into a decimal. And now multiply all these decimals together. And that comes out to 7 35 hundredths. And remember that the units are square meters. Square meter is a unit of area. All right, here's another area example. The area of a circle is pi times the radius squared. Remember that the radius of a circle is the distance from the center to the outside of the circle. So this circle has a radius of 1 4/10 meters, and they want us to find the area using this approximation for pi, 3 14 hundredths. All right, so, that was supposed to come up one step at a time. Area equals pi times radius squared. I'm going to put in 3 14 hundredths for pi, and then put in 1 4/10 for r. So again, following order of operations, I would do 1 4/10 squared first. The square of 1 4/10 is 1 96 hundredths. And then 3 14 hundredths times 1 96 hundredths comes out to 6 1,544 ten thousandths. And again, that is in square meters. All right, the last example is to evaluate 1 7/10 y minus 2 if y is 2 3/10. All right, we've done lots and lots of problems like this before, just not too many with decimals. So replace y with 2 3/10 in the expression and simplify. So it turns into 1 7/10 times 2 3/10, and then subtract 2. Do the multiplication before the subtraction. 1 7/10 times 2 3/10 is 3 91 hundredths. When you subtract 2, you get 1 91 hundredths. And that's the end of section 5.5.